Okay, so we have. Okay, so hello. Let's see. I have one request here so far for number 5.4, number 29. So we'll start with that. I'm assuming you guys can all hear me. All right. So let's see. So 5.4, number 29. All right. Okay. Okay, so for number 5.4, number 29, it says, what is the average distance? Between the parabola and the x-axis. And on 0 to 20. Okay. All right, so it looks, so this is the setup here, what? Upside down or parabola kind of pointing downwards, something like this. So if we're thinking of the average value, right, what we're looking for here is, or the average distance from the parabola down here, right, different distances here. So all we're really looking for is f bar, right, the average value of the function on the interval 0 to 20. So really, we know using the formula that f bar is going to be 1 over 20, 0 to 20 of 30x, 20 minus x dx. Right, so again, to evaluate this integral here, we distribute, and we'll get 600x minus 30x squared. And then we can go ahead and use the power rule there. So using the power rule, we get 300x squared minus 10x cubed, and that goes from 20 to 0. Right, the 0, 1 is going to go away, right? So all I care about is this 20. So we get 120, 300 times 20 squared minus 10 times 20 cubed. Okay. I won't finish it up. You can finish it up from there, but that's mainly the setup here, is realizing when they talk about the average distance from the function to the x-axis, it's really just the same way they're rephrasing now. What is the average value of the function? Okay. Eduardo, you asked that question. Does that make sense? Okay. Okay. If there's no other questions here, but I've gotten 2,000. Oh, okay. So you've done it the same way, I'm assuming, doing this. So let's see here. You have the interval. Okay. Yeah, same stuff. Okay, so let's see what I get here. So let me calculate it then. If it's a problem of getting the a different thing. Okay, so here this will be It says 2000 over 3. I'm not sure how they got that. 3, 10. Huh. Did I got everything right? 600x. Huh. No, Bahar, don't worry about the homework for the Monday, Wednesday, Friday class. I didn't go over 5.4, so don't worry about the homework. Okay, alright, so I'm not sure how they got a 3 in the denominator. That doesn't seem, let's see here. 600x, 30x squared cubed. No, I don't see it, Eduardo. Even if I plug this in, there shouldn't be a 3 down here. That's 20. I'm guessing that's a typo. Unless I'm missing something. 30x, yeah. Eduardo, I think we're good. It should be based on how it's set up. It should be 2000. All right. I don't see any way. I mean, just looking at this problem, there's no way we're gonna get a 3 in the denominator. Okay, so you are correct. You did it right. Okay. All right. Can I answer? What's the next question? Come on, guys. Someone ask a question. No? Someone's typing, so we'll see. All right, 5.2, number 21. All right, so let's take a look at that one. All right. 5.2, number 21. Okay, so this is one of those Riemann sums. So we have the limit as delta goes to 0 of the sum k equals 1 to n of the absolute value of x k star squared minus 1 delta x sub k. Okay, it says consider the following limits of Riemann sums of a function f on AB. Identify f and express the limit as a definite integral. Okay, so here, consider the following limits f on AB. All right. Okay, so let's see what we have here. So we have an absolute value. They give us the interval of -2 to 2. Okay, and we have this Riemann sum, and we want to identify, really want to see if it's a left or a right one, right? So let's see. Okay. Oh, can we do 21? Sorry. You're doing, oh, that's not it. 21. Okay. So 21 is the limit as delta goes to 0, goes 1 to n of xk star, cosine of xk star, delta x of k from 1 to 2. Okay, so for this one here, again, all we're really trying to identify is match this up with our definition of the Riemann sum as a definite integral. They give us, so just in general, any partition, so they give us the limits of integration, so that I know it's going to look from 1 to 2, right? And then here, my delta xk is my dx, and my x star is any x in the kth interval. But since I'm taking the limit as delta goes to 0, that just becomes my variable x, cosine x, dx. And that's it, right? They're not asking us to evaluate. It just says to change the notation from a Riemann sum and write the limit as a definite integral. So at this point, that is all we can do here. Okay, they're not asking us to evaluate or anything like that. All right, Bahar, does that make sense? Were you expecting to do anything different here, or what was the problem working through this example? No, we can't. At this point, we can't evaluate. We don't. We're not sure, or we haven't been taught how to do something like this. We will later, but for now, it's just a setup. Mm-hmm. You're welcome. Anything else I can help you guys with, or someone shoot me another problem? Number 25, same section, 5.2. Okay. Okay. Okay, so here, 25. Okay, so we have the integral. Okay, and I'm going to rewrite it like this. Okay, and again here they just ask us to use geometry, so not Riemann sums or anything. So setting this up, I'll just take a look at here. Okay, all right. Okay, so here we're looking for this area right here, 25. Okay, yeah, so we're looking for this, so it's just a trapezoid, right? So if we think of here, this area, right, and here, that'll be -1. And 2 state this. How come 1 turned positive and 2 stayed the same. Oh, I'm sorry, did I write this down? Oh, that was, excuse me. All right, so sorry, I wrote down the wrong region. They're both negative. Okay, so thank you. So they're both from -1 to 2. So that means that here, all right, that makes it this shaded region that I have here. All right, from -1 to 2. Right, think of it as two triangles. Right here, where the base is -1, or if we think of it just in terms of positive terms, we'll put the negative in a second here. So that triangle, the area is 1/2 base, which is 2, times height, which is also 2. And then the area here, right, is going to be 1/2 base, and then height, which is also 1. So in this one, we get 1/2. This one, we get 1. 2. Sorry. Okay, so our total area is going to be 2.5, right? And since it's below so that's our area, right? And if it's below the x-axis, we'll put that negative in front. So it's -2.5. Okay. All right. Any questions on this one or another example you guys would like me to do? That's it, guys? Oh, here we go. Sorry. 5.5, number 75. Okay. So let's see. All right. All right. So let me. Okay. So here. All right, so we're asked to calculate for 5.5, number 75, find the area of the following regions. The region bounded by the graph x sine of x squared, and the x-axis between x equals 0, so I'll just write it on this interval between 0 and pi. Okay. All right, so if we have a graph of this, just to kind of see what this would look like here. We don't really need a graph, but just so we get an idea of what it is that we're graphing here, or we're trying to find out. So let's see, we have x sine of x squared. Sine of x squared. All right, and that goes from 0. So x equals 0. And then x equals to pi. All right, so just kind of looking at our graph here. Let me get rid of some of this here. So let's see. Curly braces, 0. All right. Okay, so now okay. Oh, square root of pi, excuse me. So that changes it. I was gonna say that this made it a much more challenging problem, but the square root of pi should clear things up a bit, because I think at square root of pi, I'm guessing it's this point right here, down here. But let me just make sure. Yeah. Okay. Okay. So just looking at the region, right? We could see. All right. So that's not so bad, right? It's all above the x-axis. I don't need to find any intersection points. So really, once I see what it looks like, I have the limits of integration, and I want to find the area under the curve. I really just need to calculate the region here, x sine of x squared dx. All right, so now at this point here, it's a matter of our substitution. And again, you see the inner function here, x squared, that's our composition. So I'm going to make that to be my u substitution. And then du is 2x dx, which I see out here, right? The only thing kind of missing here is the 1/2 du x dx. Okay. All right, so now once I'm here, I could say, all right, let me plug this in. And I guess one other thing we're gonna switch the limits up. When x is root pi, u is pi. And then when x is 0, u is gonna be still 0. Okay, so now our integral with the substitutions in place are gonna be 1/2 sine of u du. Okay, and then from here, now this is one of our integrals here. Basic trig integral. Integral of sine is negative cosine. Evaluated at pi and 0. And then we see we'll get, forgive me, a positive 1. All right. Okay. How we doing? Any questions on that one? Can you guys still hear me okay? Yes, no, maybe. Can you okay. All right, it might just be you then, Bahar. But looks like my mic's on and it seems like I'm coming through clear, at least on what I can see on my end. Okay, can I take another question then? All right, 5.4, number 57. Okay, so let's do that. All right. Okay, so number 57 is up next. Okay, so here, what do we have here? This is, so problems of antiquity. Several calculus problems were solved by Greek mathematicians long before the discovery of calculus. The following problems were solved by Archimedes. Okay, show that the area of the segment of a parabola is 4/3 that of its inscribed triangle of greatest area. In other words, the area bounded by the parabola y equals, okay, so here we'll assume a is a positive integer. And the x-axis is 4/3 the area of the triangle. Okay, so up here is a squared. These are a and negative a. Okay, whatever those are, right? Just any positive integer, or I shouldn't even say integer. Any positive number. Okay, and the triangle inscribed here, like this. Okay. So if we look at, first of all, let's find that area of the triangle, right? That's probably the easiest thing to do here. So area of triangle is 1/2. The base is 2a, and the height is a squared. So here we have a cubed. Okay. So that gives the area under the triangle, right? And now finding the area under the parabola and the x-axis, that's simply the integral from negative a to a of a squared minus x squared. Okay, and then plugging this in, we get a squared to get x. Keep in mind that our limit, or our, excuse me, our variable is the x. So that'll be a squared x minus 1/3 x cubed from a to negative a. All right. Okay, and then just plugging in the values here, we'll get a squared times a minus 1/3 a cubed minus, sorry, kind of ran out of space here. Okay, so here we have a cubed a cubed plus minus x 1/3 cubed negative plus negative minus 1/3 a cubed. Okay, and then here we'll get 2a cubed minus 2/3 a cubed. And that's 6/3 minus 2/3. We get 4/3 a cubed. And that concludes, excuse me, and that concludes our proof essentially, right? We've shown that the area under parabola is 4/3 a cubed, but above I just showed that that triangle has an area of a cubed. All right. Okay, can I take another question? Or any questions on this one that I can clear up? No, you guys doing okay on the other parts of the homework? Okay, if there's no other questions, then why don't we call it a day here today? All right, so I hope that this was helpful. I mean, it was a shorter one, but we did cover a few good questions. All right, so thanks for joining me. I'll see some of you in class tomorrow, and the rest I'll see you on Friday. Okay.